Hello, everyone. We're going to have a look at the index law, dividing indices with the same base. So let's have a look and unpack an example. So if I had a to the 5 divided by a to the 3, what is this asking? Well, a to the 5 is a times a times a times a times a, because the base is a and we're timesing it by itself 5 times. Divided by a to the 3, which is a times a times a. Now, using what we know about fractions and simplifying, whatever we multiply on the top, we can simplify with what we're multiplying on the bottom. So an a for an a, an a for an a, and an a for an a. And we're left with a times a, which is a squared. Okay, so that's one. Let's do another one. Let's do y to the 7 divided by y to the 2. What's that question asking? Well, y to the 7 is y times y times y times y times y. And we've done 1, 2, 3, 4, 5 times y divided by y squared. There's a y on the top, y on the bottom, y on the top, y on the bottom. What are we left with? Y times y times y times y times y, which is y to the 5. Now, we want to see is there a connection that we can make between what the indices or the powers and we're dividing them and what our answer is. So from 5 and 3, we get 2. And with our 7 and 2, we end up with 5. And hopefully you can see the connection is when we are dividing powers with the same base. So x is the same base in that thing I've just written there. We subtract the powers. So 5 minus 3 gives us 2. 7 minus 2 gives us 5. So we can say x to the power of m minus n. And that's the law that we're going to work with. So over here, if you'd like to give these a go first and then try them, just pause the clip now. So let's have a look here. We're going to use this law. We've got the same base. They're both a's. We have a power of 10 and a power of 7. So 10 minus 7 will give us a to the power of 3. Next one. Hopefully you've already tried these. We have the same base of x. So there's the same base. We've got a power of 12 and a power of 5. 12 minus 5 is 7. So it's x to the 7. This next one, we've got the m's. So that's a power of 8. And this is a power of 1. I'm just running 1 there that we haven't written. So if there's no power written there, we assume it's m to the 1. So 8 minus 1 will give us 7. So that's m to the 7. Now what about the other one? The other power is the n's has a power of 5 and 3. So 5 minus 3 will give me n to the 2 because 5 minus 3 is 2. Next one. This time round, we've just got some numbers out the front. So you see these numbers here. They're just numbers. You treat them as if they're just numbers. So what is 20 divided by 4? Well, hopefully you can do that. And you get 5. So that's the answer there. And the next part, we need to look at the indices again. So the m has a power of 5 and the m has a power of 2. 5 minus 2 will give me 3. So it's m to the 3. Now the p doesn't have anything else. There's nothing else to simplify with. So we just leave it as p squared. Okay, last question. We have a power, we have some numbers out the front. Don't worry that they're a minus, you still just treat them like they're numbers. Now, what is 6 over 4? So you can either do that in your calculator and get 6 divided by 4 and you get 1.5. Or if you simplify your fractions in your head, you knew that 2 goes into 6 3 times and 2 goes into 4 twice. And you can leave it as a fraction. But we can't forget a negative because it's negative 6 on 4. So we can leave the number as a fraction if we want. And then again, we go, okay, we've got m's, it's power of 7 and the power of 6. So 7 minus 6 is 1. I can just write it as m. I don't need to write the 1. And this one does have a power of 1 there that I haven't written. So I'm just putting the 1 there. 3 minus 1 will give me 2. So it's n squared. But remember, I did say you could also write it as a decimal, minus 1.5 mn squared.